Alright, today we are talking about 4.3a circumference and arc length. Target 3, starting day 1. Determine and calculate circumference, arc length, area of a circle, and the area of a sector of a circle. This is Mr. Custodio and
Mr. Lulo.
And make sure you guys take notes like you have been, so here we go. Alright, first on to the vocabulary. We have a couple of vocab words that are on your note sheet, circumference and arc length. And there's almost a hidden one that we need to discuss as well after we discuss the two ones that are already on your sheet. So imagine for circumference that we have a track and we have a man running on the track. We'll also put another man standing in the middle of the track watching the guy run around. Okay, so for the circumference, the definition is the distance around the circle. And we all know that tracks aren't really a perfect circle, but it's the idea that you're running around and how far that person's running would be the circumference or the distance around the circle. So if we take this man, for example, he will run all the way around backwards because we can't really rotate him, and that would be one full lap, which would be the circumference of the circle. The official second vocabulary word is arc length, which is the measure of part of the circumference. So we are only talking about, from Jersey for a second, we're only talking about just part of the circumference. So if I take this guy here, and let's say he's just starting to train for a marathon. So let's pretend that he's starting to run, he's trained day 1, and he starts running along, and then he starts dying about right here and stops. So this guy started here and only was able to make it to about here. Because this is part of the circumference, that's what we call the arc length. Alright, the third vocabulary word is arc measure. Now the definition of arc measure is the angle that an arc makes at the center of a circle. So taking into account the man that just ran part of the circle, which is the arc length, the guy in the center is timing him almost like he's his trainer. So he's watching him. That's the starting point. So he's at the center of the circle. He's watching him run, and he's cheering him on, go, go, go. So as he's running along the track, he's turning his body, and then he sees his partner dying, and then he's dead. Well, not dead, but he's just super tired that he stops. The angle in which he turned from here to there, that is called the arc measure. It's not a length. The guy in the middle did not run any distance whatsoever, but his body rotated at an angle which is correlated with the arc length. That degree or that measure is the arc measure. Now there are two formulas that you can use to find the circumference of a circle. The first formula is C equals pi times d, which is the circumference is equal to pi, which is a constant that means 3.14159 something 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 that's so long that we just use pi as a more accurate answer. That number, pi times d, would give you the circumference. Or you can use circumference equals 2 pi r. The circumference, remember, is the distance around the circle. So these two formulas would work depending on what information is given. The diameter is the entire distance from the center of the circle, or not the center, but from one side of the circle to the other, passing through the center. 2r, well, the radius is just half of the diameter. So both formulas would work, just depending on if you can understand the relationship between radius and diameter. So either or would actually work depending on the information that you're given.
Okay, so let's do an example using circumference. Example 1, find the indicated measure. So letter A, we're finding the circumference of a circle with a radius of 11 meters. Okay, so if we're not given a picture, let's draw one. So I'm going to draw a circle first of all, and then fill in the formula. So always write down what formula you need. It's a good habit to get into. So for A, since I'm finding the circumference, I'm using the formula for circumference, which A is C equals 2 pi r. Next step, make a list. C equals and R equals are my two variables, and I put C equals there just in case we have an example where we're given the circumference, we want to account for C as well. Okay, so let's fill in what we know. I know that my radius is 11 meters, so if I were to draw that in on that circle, that's what a radius of 11 meters would look like. Okay, what am I solving for? I'm solving for the distance around the circle, which is the circumference. So I fill in my formula with what I'm given. C is equal to 2 pi, and I filled in 11 for the radius. Okay, so I can combine my like terms, which are 2 and 11. Since I'm multiplying, I can multiply those two numbers together. So I will get C equals 22 pi meters. Okay, so we found the circumference. Now in this circumference, we're leaving the pi in the answer. So if you leave the pi within this answer, we call this the exact answer. Because pi is a constant number, 3.14159 something, it goes on for forever. The second that we round, we're approximating the answer. If we want an exact answer, we leave in the symbol of pi to say that, okay, pi is in here, so it accounts for all of the digits of pi. So what if I wanted to find my approximate answer? I would just multiply 22 times pi to get 66.12 meters. So I filled in two squiggles instead of an equal sign because now that represents an approximate answer. So remember, the second that you round, you are approximating an answer. Okay, moving on to letter B. I'm going to erase my picture and redraw it. So look at that perfect circle. So in B, I'm solving for a radius of a circle with circumference of 18 yards. So keyword I see, circumference. I'm using my circumference formula, C equals 2 pi r. So let's make a list and fill in what we know. We are given the circumference this time, so I fill in the circumference. And what I'm solving for is my radius. So that's what the circumference looks like, 18 yards. I need the radius, the green part. So let's fill in the formula. 18 is equal to 2 pi times the radius. Okay, now I need to get r by itself because I'm solving for r. So what is attached to the r? We have a 2 times pi times r. Since 2 and pi are being multiplied all through to r, we can divide by 2 pi in order to cancel out those terms on the right-hand side. So we divide by 2 pi on both sides. The 2 pi's cancel out. We're doing two steps in one. Instead of dividing by 2, then dividing by pi, we're just combining them into one step. Okay, now I need to simplify. 18 divided by 2 is 9, and since 18 is the big number and it's on top, that means our 9 will stay on top and our pi will stay on bottom because I didn't divide by pi. So 9 divided by pi is my exact answer. When you have pi in there, it's your exact answer. What's my approximate answer? If I actually do 9 divided by pi, I get 2.86, so that is my approximate answer. So if I can fill in my radius on my circle, r is 2.86 yards, and we are done. Okay, you know the drill, so pause the video and do this you try now on your own. If you get a different answer than we did, then ask a question about it in class on Monday. Okay, so now we are going to move into the arc length corollary. So, in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. So the three words that I highlighted are ratio, is equal to, and ratio. So that means we're going to be setting up two ratios and setting them equal to one another. So let's do a little bit reminder flashback. When you have a ratio or a fraction, that represents the part of a whole. So 2/3 of a cup of something means you have 2 out of the 3 parts of that cup. If we're setting these two ratios equal to each other, that means we'll have a part over whole equal to another part over the whole entire thing. So if we relate that to our corollary that we're going to be doing, we come up with our formula. So in a circle, the ratio of the length of the given arc, so the arc length of AB, so that's the part of it, over 2 pi r, which is the circumference. So remember, the arc length is a part of the circumference. So we have the part over the whole is equal to the measure of the arc, AB, over the measure of the whole entire circle, which is 360 degrees. So this is the main formula that you're going to need. So put a box around that formula. So let's explain what these are. Okay, I'm going to use the same colors that I did in the formula to describe what's going on in relationship to the picture. So the arc length of AB is the part that's in dark purple. That's a portion of the circle over the circumference. So the circumference is the whole entire circle. So we have the part over the whole. Okay, so now we're going to talk about the measure of the arc. So remember that the measure of the arc is kind of like if a guy was standing there watching a runner run. He's measuring the distance of the arc. So the measure of the arc is going to be that green portion right there. That's the measure of the arc, divided by the measure of the whole entire circle, which is complete distance around, which is 360 degrees.
All right. We made a mistake in example number 3. If you look at both diagrams, in number 1 it says arc length of AB, and the circle underneath it, well, there is no arc AB. So when we go over these examples, make sure you switch the diagrams appropriately and just pay attention to the one for number 1, the circle on the right, and then for number 2, the circle on the left. So in this example, we have to find and use arc length. So we have to use the diagram to find the indicated measure. So for number 1, if we have to find the arc length of AB, first of all, pay attention to the diagram on the right. Okay, we need to find the arc length. So I'm going to write down my proportion, arc length, which is part of the circle, over the circumference 2 pi r, equals the measurement of AB, which is the arc measure, over 360. Alright, so we have to find the arc length. The arc length goes from A to B, and we don't know what that distance is, so we put an X by it. Everything else we can probably figure out. So then arc length would be X divided by 2 pi, and our radius is 2. So then that ratio is equal to the arc measure AB over 360. So our arc measure is 88 over 360. In order to solve this proportion, or solve specifically for arc length, we have to cross multiply. So our first set of cross products would be x times 360 equal to, the other set of cross products would be 2 times pi times 2 times 88. So then, since we're trying to solve for x, I'm going to divide both sides, I'm going to simplify the right hand side first and get 352 pi. I'm still giving my exact answer. So now I'm going to solve for my x, which represents the arc length. I'm going to divide both sides by 360, which cancels out my 360, so I'm just left with x. So then x would be equal to 0.978 pi. That would be an exact answer. So then if I had an approximation incorporating pi in my answer, it would be about 3.07 meters. Now for part 2 of example number 3, we are focusing on the measurement of arc RS. So we don't want to look at that diagram, we want to look at this one for number 2. So because we want to find the arc measure of RS, we're going to write our proportion, arc length of RS over the circumference. So arc length is still the part of the circumference. And because we have just the radius, it looks deceiving, but the radius is 12.3. So I'm going to use 2 pi r as my formula for my circumference. And that's going to be equal to, that ratio is equal to, the measurement of arc RS over 360. Now I'm going to substitute what I know. I know that the arc length of RS is 38. So I'm going to substitute 38 divided by 2 pi, and our radius is 12.3. That's equal to RS. Well, we don't know what RS is. We don't know what the arc measure of RS is. So I'm going to put a variable x on there, and then my 360 still stays there. Now to solve this proportion, I have to cross multiply. My first set of cross products, 38 times 360, ends up being 13,680, equal to my other set of cross products, which is x times 2 pi times 12.3. So I'm going to divide both sides by 2 pi times 12.3. So just to clarify, you could simplify 2 times pi times 12.3, but I just didn't in this case. And so when I divided both sides by 2 pi times 12.3, my 2 pi's cancel out, my 12.3's cancel out, so I'm just left with x on the right side. And that's equal to 177.01 degrees. That would be the arc measure of RS.
Okay, so here are 2 examples for the you try now. Try them on your own. Honestly, you want to try these examples on your own, and then if you don't get the same answer, that's where you write down a question and get stuck. So we're still learning how to do this flipped classroom model. That's something that's going to really be helpful for you guys. So pause the video, work it out on your own.